I don't think there's anything special about this example, how we're going to, in terms of how we get started with it. I think there's something that we can notice at the end. But following up on something we finished with yesterday, what in this question gives us a hint on what might be factors, what might work for this question? Jason?
Yeah, it has to be a factor of the negative 16. Yep.
So this number here, we can predict. A lot of mathematics becomes easier when you can make more and more predictions about what your final answer will look like. When you first learn to factor, one of the important things is that your answer looks like this. Like you kind of have to know that that's what you're working towards, right? So I can predict that my answer might look like this. Maybe not for sure, but it might. I have 4 brackets because it's degree 4. So I'll have up to 4 factors. I don't have to have 4, but I could have up to 4. If I got a quadratic at the end that didn't factor, then I'd be done. I'd leave it as a quadratic, okay? But I also know that these 4 numbers or 3 numbers or however many there are going to be have to multiply to 16. So unless one of them is a fraction, which doesn't really make sense, that's kind of defeats the purpose of factoring, is we're looking for integer factors, right? So we're not going to get a fraction. There have to be factors of 16. So 2, 2, 2, 2, maybe, right? Or 1, 4, 2, 2, or 1, 8, 1, 2, or something. Anyway, right? Like those are the only possibilities. And I suppose you could keep track of the ones you've already done, and that would give you hints into what might be left. But anyway, I don't know for sure if it's a 2, 2, 2, 2 or that kind of thing. But what about 3? Like, would I bother checking 3? My guess is I wouldn't even get to 3 here because probably 1 or 2 will work. But there's no point in checking 3. There's no point in checking 5 if you got that far. Still start with 1. Go from there. But I gotta imagine if I was doing this question, I checked 1 and -1 and 2 and -2 and hadn't found one yet, I'd go back and recheck my math. There's gotta be probably a couple of 2's in there somewhere. So has anybody got it? -2? All right, is 0. Therefore, x plus 2 is a factor. Okay, perfect. What do we do next? All right, let's do it. So you can go ahead and try that. So my factor is x plus 2. And I write out the coefficients 9, 36. There's no missing terms, right? There's no ghost terms. So 32, -16, -16. And here's my check. I got a remainder of 0, so it has to work. All right, therefore, f at x equals x plus 2 times 9x cubed. Again, as I'm doing this, I'm checking some of this work. Like 9x cubed times x is 9x to the 4th. Not only is it a good idea to, I don't think you would have a mistake there if you're doing everything else right, but it's also just a nice reminder that factoring is the opposite of expanding, and we can always expand back to check. Like it's always something you should keep in mind. Plus 18x squared. Also, just the fact that the degree is reducing in every step, like just thinking about why is it reducing, all those things are good to have a better overall understanding of what we're doing. Okay, so then what am I going to do? Does anybody want to help me out here? What's our next step? What should we do?
Set g at x equal to the second bracket and then fix that equals 0.
Yes. So we want to look for something new, and we don't want to use f at x because we need to use g at x. G at something equals 0. So what should I try here? Has anybody got this far? Go ahead and try it. Okay, I'm going to leave that with you for a second. Go ahead and try it. Also, I know that like there's going to be some kind of tricky trinomial, complex trinomial at the end because of the 9, right? If like when we look for these factors that are just x plus 2, x plus 1, x minus 1, when we're looking for those, it doesn't account for any factors that are like 3x plus 2, right? That's not going to happen in here. Those are lost. So if it was a question where all of them were like that, 3x plus 2 times 2x plus 1 times 4x minus 1 times 2x minus 3, like this wouldn't work, right? We wouldn't be able to. This only works when we can find one or two factors that are like x plus or minus something, which is fine because that's all I'm going to ask you to do for now. But that's something that's interesting to think about. Couple of people, okay, so some people are having trouble finding it. Some people found that -2 worked. So if you tried -2, or no, -2 worked the first time. Does -2 work again? So we didn't check. So because we used it the first time, we didn't check it again the second time. Why can it work again? Well, let's do it and let's find out. So -2. I thought it was the opposite. It's the other one. Therefore, x plus 2 is a factor. Now here's a really good, this is actually kind of the point of this example. It's because if I had gone back and checked in my original f at x, of course -2 is going to work. It worked the first time, how would it not work the second time? That's why we have to do this step, where g at x is this, and we have to check this now for factors. Because it turns out it was the same one twice, and that you wouldn't notice that if you were only punching it into that original equation. Does that make sense? So you have to go with what the result of dividing here, this quotient. You have to check for factors in that. Okay, so go ahead and do that. If I'm going to use the trick, so I'm going to say therefore, and if you want to watch, I'll walk through it again. So it's going to be x plus 2, and then my second x plus 2, and then it's going to be some trinomial here. And I saw a lot of people doing the learning goal are using synthetic division. That's fine, that's great, but it will speed things up if you, and sometimes these tricks seem really confusing at first, but if you kind of push yourself, then all of a sudden it clicks and it's actually pretty easy. So x times something has to give me 9x cubed, so that's obviously got to be 9x squared. Now this next part is actually kind of tricky. So this is a case where, unless you were very confident, you might get partway through, confuse yourself, and be like, then just go to synthetic division. It's always nice to have a fallback plan that always works, that's sort of more algorithm oriented. Because on a test, if your nerves are going, you might start to confuse yourself or overthink things, or like your brain's just not firing right, and then you can fall back to the steps. But if you really got this, when I do, so I'm looking for 18x squared, okay? And two terms are going to add up to that. And one of them comes from this times this, and the other one comes from this times the thing we don't know yet. So because there's only one unknown in that equation, we can work it out. And so let me go back here. 2 times 9x squared is 18x squared. Well, that's what we want. We've already got it. So what does my middle term have to be? 0. Very nice. So this is actually going to be plus 0x, and I'm going to write it for now. But if you did synthetic division, the 0 would just pop out, right? So you wouldn't have to I could see this being confusing to some people. Like, wait a minute, that doesn't make any sense. It does make sense. And then 2 times something gives me -8, so that has to be -4. And I can double check to see that the 0 is right. But this is, so I wrote it this way for clarity, but we actually want it to look like this. 9x squared minus 4. Okay. And so a little bit trickier, a little bit different, but try not to get tripped up. Like, we want to get to the point where we're good enough at this, where even these ones that are a little bit weirder, we can work our way through, right? But it's a little bit more challenging. So can I factor this result? What can I do with it? What do you think? Yeah, go ahead. And if you didn't notice that and you tried to do synthetic division or complex trinomial division or something, I mean, again, that would work, but it's a lot easier if we can recognize it for what it is. It's the difference of squares, right? Everything's a perfect square. It's two terms. It's difference of the two. So then this is x plus 2 times 3x plus 2, 3x minus 2, or even better, x plus 2 all squared. There we go. So I had two terms that were the same. That's why it might have been tricky to find. And then my other two terms, look, were 3x and 3x. So that's why we can't find those with remainder theorem. That's actually not true that we can't, but it makes it a lot harder. And generally, you don't have to. But the factor theorem, the way we're using it, we wouldn't find these two last terms. So we have to, I guess what we kind of learned here is if you used a number once, it could come up again if the same factor is in there twice. X plus 2 all squared. Okay. Any questions about that or anything else having to do with factoring so far? We're just going to do 3 more examples, and each one of them has a little twist. The good news is, again, using factor theorem and synthetic division, you could have formal steps to solve anything. But if you remember from grade 10, factoring is a little bit of an art, and some of it comes from how fast you can do it. Because if you take 10 minutes to factor something that really should take you 2 minutes, then you may run out of time on a test. So it's great if you can do it, but you want to be able to do it in a reasonable amount of time as well. In this unit, I mean, we're almost done this unit, but in this unit, you can see there's a lot of factoring. In the next unit, there's a lot of factoring, but we do other stuff with the factoring. So, the factoring is just one step. So it's got to be done moderately, reasonably fast, or quickly. Not fast, but you saw in the homework yesterday that you were graphing, so already sketching. I hope you did. If you didn't, please ask. If you're not sure, because that will definitely be on the test, even though we didn't do an example in class. We did sketching earlier in the unit, and then we moved into some algebra skills. How does that relate back to the sketching? Well, now we can sketch more kinds of things because we can put it into a form that we know how to sketch, right? That's the idea. So those sketching questions from the practice are really important. Make sure you practice those and yet you made that connection. Okay, so let's take a look at this one. Does anybody notice anything about it? Yep. Yeah, very nice. There's 2 terms that are missing in there. Yeah, what else? Anything else? You factored this before. We didn't think of it as a degree 4. Maybe you did. Maybe your teacher talked about it. We didn't, but we didn't know about polynomial functions. We didn't really know anything about a degree 4. We were just doing it in the grade 10 way. But you've probably factored or been asked to factor something like this before. What makes this familiar? What makes this a grade 10 question is that it's in the form like a quadratic, isn't it? Something squared plus something plus a constant. Okay, don't write this down. I'm going to scribble some stuff here. So this is like something squared plus something and then a constant. But what is that something squared? It's x squared. So it's like x squared plus x minus 12. Or maybe I should use a's or something, right? But it's the same kind of idea. It's in this form. Is this something that you know how to factor? I hope so. That's a simple trinomial, and it's definitely factorable, which means we can use that same strategy to factor that, and that's what we're going to do right now. And this will always work when you have like 3 terms, and the exponents, we've got a constant, and the exponents are such that the first one is twice the second one, right? So 6 and 3, or 4 and 2, or 8 and 4. I mean, any of those would work. You won't probably see much beyond 4, I don't think. Maybe 6, but. Okay, so we're just doing it the same way. What are 2 numbers that multiply to 12 and add to 1? Yep. 4 and 3. So I've got something, and you said positive 4 and something minus 3, but I don't put x in there. What do I put? It's x squared. And those aren't factorable anymore. If this was, so again, I'm just going to scribble here, don't write this down. If this was x squared minus 4, which I could definitely see that happening, I'm actually kind of surprised that didn't happen, then I would keep going, right? X plus 2, x minus 2. And you could kind of, like, this is something that we will do in the next unit, where I could do this as x plus the square root of 3, x minus the square root of 3, right? But we don't have to do that for this. Could we switch the signs? These signs? Well, if I did that, then when I did this, I would get negative 4 times positive 3 would give me negative 12, but negative 4 plus 3 would give me negative 1. So in this case, this is, I think, the only right answer, and so we're done. So, I mean, this is like, we're also noticing that our answers don't always look like this one, where you have 1, 2, 3, 4 linear terms from a degree 4. It doesn't always work out that way. Sometimes we are done here and we still got an x squared, but that's as far as we can go. Yep.
When we usually factor it, we know like what our zeros are. So in this case, like how could you graph this with the x squared?
Ooh, so nobody said anything that we could, that they're all graphable, did we? But that's a good question. So this question we were asked to factor, if this question we were asked to graph, how would we do that? Anybody have an idea? Okay, so let's see. X squared, think about it while I'm typing this out. X squared minus 3. So I wouldn't ask you to graph this. What do you think these 2 roots are?
There is a black Volkswagen license plate DK DB408. They have left their lights on. Again, DK DB408, black Volkswagen, their lights are on. Sorry for the interruption.
I was going to say square root of negative 4 or square root of 3, but I don't know if it's positive or negative.
Well, one of them's positive and one of them's negative. Let's see what they are. If I think I should, whoops, give me a break. Hey, what's going on here? That one worked. Negative 1.73. Does anybody recognize that from trig? We see it a lot on our calculator. It is the square root of 3. So those are plus or minus root 3. So where's the other one? But when I do this, so folks, this is not something you really need to worry about. It's not going to come up, but it's an interesting thing to think about, and it will help for the next unit. If I were to try to figure out that part, it'd be x squared equals negative 4, so x equals plus or minus the square root of negative 4, which is an imaginary number, right? That's not going to work out. So those roots are not on my graph. They're somewhere else invisible. But when I'm graphing like this in 2 dimensions, you don't see those. So this is a quartic that only has 2 x-intercepts. They come from there, and the other 2 are non-real. So they don't appear on our graph. If we learned how to graph imaginary numbers, then we would see them there. But basically, I would never ask you to graph this. You wouldn't be asked to. Okay, what about this one? This one's really hard to recognize. I'm going to point it out. I wouldn't expect you to recognize it unless you had some weird passion for this process in grade 10. And it's a small thing. It only comes up once in a while. But it turns out it is a lot faster to factor it this way if you notice it. So like if you did synthetic division and that kind of stuff here, I mean, if you're good at this, it wouldn't take you that long. But if you notice, anybody notice? Wow, very good. Remember factor by grouping? We do it for like a day, even half a day in grade 10, and it's really weird and nobody really gets it. And then it doesn't come up in grade 11. But turns out it's useful in MHF and possibly in calculus as well here and there. So if you notice that this is factor by grouping, awesome. It's way faster. How would you notice? Well, these 2 terms look like they have a lot in common, and these 2 terms look like they have a lot in common. I can common factor both of them. In grade 10, this was a weird thing, but you guys are way better at this stuff. Like your algebra skills are way beyond what they were in grade 10. So, you may have not loved this in grade 10, but you might find it easy now. So I would retry it. I think there's a couple in the practice tonight that work out this way. So what you do is you common factor both. So I can pull out an x squared term of this one, and I end up with x minus 1. And then it's not like common factoring is usually thought of take out as much as you can. But that's the way we teach it, but that's not actually like some kind of math rule, right? It ends up being about what's convenient, what gets us where we want to go. So what do I want to factor the second 2 terms by in order to get this as a factor? Negative 4. So do you pull out the negative or don't you? Whatever's convenient. If I factored this in such a way that 4 happens to be the greatest common factor, but maybe I wouldn't even do that. Like maybe I wouldn't even factor out the greatest. Maybe I would factor out part of it so that I get x minus 1. And the whole point of factor by grouping is that these 2 brackets have to be exactly the same. And then I pull those out front, and my second bracket is what's left. The x squared and the minus 4. So again, you can do this with regular old factor theorem and synthetic division, but if you notice that was a lot faster. A lot faster. What do you think? Absolutely, of course. There's almost never a time that I can think of where the answer to that would be no, do you keep factoring? The instructions do say factor fully, which means if you can keep factoring, you do. But it's almost always better to have these things fully simplified. Any questions? That's it for that one. One more small trick to this one. Probably it came up in the practice and you've already kind of thought about this one, but as you're writing it down, what jumps out at you? Yeah, and then go ahead and do this one. I'm going to let you do it. So don't shout it out, but let's see if people recognize it. Blake, what was the first thing that you told me that you noticed? There's no constant. And Cassidy, tell me what that means we can do. Very good. We can common factor out an x. So that's always going to be true if there's no constant, because that means there's an x in every term, right? So whether you recognized one or the other or both, what does this do for us? Well, oh boy. Oh dear. There we go. What it means, instead of factoring a quartic, we're only factoring a cubic. Kind of nice, kind of easier, right? So that now I do have a constant, so I can't do it anymore. It's possible that you could have a question where you could factor out x squared and make it even smaller, but it would have to be set up in that way, right? So there you go. And then we just factor. Does anybody have a factor of this? Anybody find one yet? 36 has a lot of options. 2, 3, 4, 6, 9. Whew, lots of possibilities. So anybody find one? Somebody must have. No? All right, let me know when you do. I don't know if you've noticed, but something that I often do is I look at which terms are negative. If all the terms were positive, I don't want to answer this question right now, but you can think about it. If all the terms were positive, what would that tell you about the possible factors? Don't answer it, because I want everybody to think about that. But I'm glad that some people think they know already. That's good. 2 of them are negative. Look at the coefficients. They're very big. So if I add some positive small things and some negative big things, that's not going to work. So what do I do? Well, we have some options here. If I put a 3 in, that's going to make these become a lot bigger than those. So that might help. Or what about like a -1? Because a -1 will flip this to positive and will flip some of this to positive. But it looks like that's not going to work, because that's going to be 36 plus 27, which is 9, and that's not going to work out to 9. So 1 and -1 aren't going to work. Like, you can kind of see, if you can do some of this in your head, you can kind of see that before you start. 1 and -1 aren't going to work. 2 might. I don't think so. -2? Possibly. And then go on from there. Oh, question? Or did you find one? Okay. What did you find? -3? Yeah. -3 works? Okay, let's do it. Did you try +2, -2, +3 before that? And none of those worked. That's a lot of work just to get one factor, isn't it? That's why, like, remember when I said yesterday, if you're hitting 5 and 6, there's a good chance that you've missed something, because that's kind of like a lot of busy work for no reason. It's really important that when you're doing this, I mean, we've talked about this, it's maybe obvious to most of us or all of us, but that if f at -3 works, it's x plus 3, that's the factor. Because if you flip that, it's not going to work, right? It may or may not work. In some cases it might. You might fool yourself into thinking that it's working, but all right, so. Is that right? That's -36. All right, I think that's right. Questions?